So here we're going to look at notes 3-2, and I am on page 166. So notes 3-2, page 166. And remember that whatever I write down or underline or highlight, please make sure that you do the same. Okay? So here we're talking about what are different representations of a function, and we've kind of already talked about this. We know that back to that vocab, we can have ordered pairs that can be in function form. We can have tables, graphs, equations, and the mapping. Okay, so let's go ahead and look at this first example. This example is talking about that we have a 10,000 gallon swimming pool and it needs to be emptied. Okay, and so if we have 10,000 gallons and it says that we are emptying it by 7,200 gallons per hour. Okay, and we want to know how long is it going to take to empty this pool. We have a rate of change or a slope here. Okay, and we know, I'm going to underline it right here. This is in the box. We know that the rate of change is how much it's changing by per hour. That per is going to be helpful for those. So 720 gallons per hour, that's your slope. We also were told that 2,000 gallons has already been emptied. So that would be our initial value. Okay, that would be our initial value here, which is your y-intercept, your beginning point. 2,000 is already gone. Okay, and we want to find out when will we be at the 10,000 mark because that means the pool is empty. This is in the form of y equals mx plus b. Okay, this is in that form, slope-intercept form. And so we had mentioned earlier, when we have it in slope-intercept form, it is what we call a linear function, meaning that it is going to make a straight line. Anything in the form of y equals mx plus b is going to be what we call linear. So today we're really looking at, we're going to be asking ourselves kind of two questions. Is it going to make a straight line? So is it going to be linear or not? And then we're going to ask ourselves, is it going to be a function? Meaning, are all my x values different? And when we are in this form, y equals mx plus b, it's going to be both. It's going to be linear and it's going to be a function. Let's go ahead and look at our next example. So in example 2, it's talking about something that is nonlinear. So let's think about that. If we're nonlinear, that means it's not going to be a straight line. Not a straight line. So that would be what I would underline there. You can see here that we have a table. Okay. And on my table, I have length values, and on my for my x and my y, I have the area. We're talking about the area of this square here. And we can see that we have a curve. Okay. A couple things I want to talk about. It is nonlinear because this line is curving. But is it a function? Let's ask ourselves that question. So let's look at the x values. Are all my x values different? So yes, a function. So we can still be a function even if we don't have a straight line. So we have, yes, a function, but this is non-linear, meaning my line is not straight. Okay, so we're kind of, again, looking at two different things here. Okay. Now let's look at example 3, and this is where we're going to get into identifying functions from graphs. Okay, identifying functions from graphs. And we have something called the vertical line test. And I want us to write that down, and I'll go more in depth in class when we're back in class together. But the vertical line test. What the vertical line test does is if there is a vertical line, vertical means up and down. If there is a vertical line that goes through 2 points, so right here on this graph, This vertical line is going through 2 points. That means I have two x's that are the same. So that means that this is not a function. Oops, it's not letting me write very well. Let me try writing that back out. Not a function. The reason is because you're going to have, if you were to write those two ordered pairs down, these two ordered pairs would be -2, 1, and that would be this point, and my other point would be -2, 5. So we have two x values. If we ask ourselves the question, are all the x's different? The answer here would be no. The answer would be no. Let's go ahead and look at the first two examples. All of these examples, I should state, all of these examples are nonlinear because they're not straight lines. Okay, they're all nonlinear, not straight lines. But the last example is the only one that is not a function. All of these, if I were to draw vertical lines, think of the vertical line test, there's only going to be 1 point on each vertical line. So these are all a function. Yes, a function. So these two are a function. They're nonlinear, but they are a function. So I know we're kind of looking at two things now. Let's go ahead and look at the key concept and summarize it here. So looking at my key concept box, it says that you can represent a function in different ways. We have a table, we have a graph, we have an equation. We could add, we've looked at arrow diagrams. And we've also looked at ordered pairs. So those are the 5 different representations. Okay. Here it says a day at the amusement park costs $10 for entrance fee and $2.50 for each ride ticket. They wrote that as an equation. So if we look at our first example here on the left where it says table and graph, these would both, I'm going to just draw a line down here. These are both linear because they're in the form of y equals mx plus b, and it creates a straight line. And they are functions. Okay. So they are both linear and they are both functions. On the other side, here, they talk about a nonlinear again, and then they also talk about what linear means. Nonlinear is not a straight line on our graph, and linear is a straight line. So we're going to do the practice in class together. Just please make sure you highlight and underline everything that I highlighted or underlined. And I can answer any questions in class. Have a good one.